Today we're going to look at the modeling and simulation of the space vehicles and the International Space Station. But in this case, supply the technology that we use from ground vehicles to this new field. So if you look over here, I'm going to talk a little bit about what computer simulation is, how we do the airplanes of the future, the concept on how to build models, how do we use the to produce models for the International Space Station. So there are several software tools that we use in here. We look at it, SCAMG, MATLAB, and Simulink. We use Nastran 4D. We use the NASA has their own software, and Working Model 2D. We use DSAT for the controls, and a combination of SolidWorks or ProEngineer with Patran and Nastran and SimWise 4D, which are for dynamic analysis. Let me just disappear from here. What we are going to look at it is the understanding the space station assembly with this technology that we use for ground vehicles, which is solid modeling, finite elements, dynamic analysis, and vibration analysis. Let's a little bit about the space station. Space station is basically a gigantic laboratory. It's the size of a football field. Originally, the space station was commissioned by an organization, you may see by this color coded. All the red is what the Russians were to do. The yellow one is what the United States would do. And then you had several different other ones. Like in this ones was where the Russians would contribute this model, or the Japanese would do this centrifuging here. And then you had from Canada, they had this robotic arm. And from Italy, they have the multi-purpose logistic module. And from Brazil, I think there is also a small thing. Don't remember where that one is. But if that tells you, but in reality, there were about 24 countries that participated on the space station. Here was the basic idea that came from NASA, and that is the mission 1R of the space station, which had this body in there, and it had these two panels. Now in here, it expanded to another mission with different bodies up to the time we have this kind of mission. And then this kind of mission. And then of course this one. So these are the basic concepts that NASA had to assemble this station up to mission 5A and finally mission 12A. So when you have mission 12A, you have a lot of bodies all over different structures as well to hold it all together, and the blue panels are the solar panels that actually collect energy from the sun to produce electricity. Here's another view once the space shuttle is connected to mission 12A, but this was the original parts that I showed you earlier, but this is connected to undock to the station. What the space station does is it tracks the sun as it goes around the Earth, to the point that it will be a maximum utilization of the sun's energy to produce electricity inside the station. And not only that, the air conditioning and all that stuff. Yeah. So, what do we do next? This is the first model tried here at CSUS. This was a combination of a simple body here, simple body here, simple body here, and put it all together to study the vibrations and the deformation of this under the natural frequencies. So you have the blue section in there, which is the original shape, and you have the deformed section. This is a model of a STS-107 with the space station and the space shuttle. This is, we have moved a lot beyond the previous one. All this was worked out in, we tried two programs at the same parallel, SolidWorks and Pro Engineer. And so we use both of those to produce finite element models, as you can see they're mentioned here, of the airplane and finite element models of the space station. So what I'm trying to say is space station is modeled using the basic modules of the produced in SolidWorks and Pro-E. And the idea now in doing this is because we could do the maneuvers and do some testing of the modes of vibration. And in fact, that's what this is. This is a test of the modes of vibration of the space station to test how it would deform. And this is a different picture of the, basic model of the space shuttle. And this has different modes of vibration. You have mode 4 at 0.0015, and then you have mode 10 at 90 hertz, one at 156 hertz, and one at 190 hertz. Okay. This is a study of the maneuvers. So this is just like in ground vehicles, we're interested on collisions or things like that. Space station also. Here we have the space shuttle as it docks to the station, produces a collision, but I mean it's a control collision. And these are the different modes of vibration that the station would have. Different configurations of deformation are called modes of vibration. Let's see, there you go. Okay, these are the different configuration. It's a configuration that with links to different models, to different deformations. So you can see this is the real system, and this is our model over here. And so this Mission 12A was assembled using this technology, and we tested the vibration modes of Mission 12A at different frequencies. See, these are different configurations of the station. To as the frequency is going up, the changes are more dramatic because the natural frequency of the station is very, very low, less than 1 hertz. Now here you can see a increase in the disturbance, 0.0212 hertz. This is a one for comparison of different modes of vibration of the station that was done using Nuston pattern 4D. We could generate finite element models of the shuttle arm and the station. We could do system integration with the space vehicle, visualize the modes in different configuration, study the rotation of the joints and things like that. Therefore, we can, let's see, let me put that final slide also to talk a little bit more about it. In here, let's see, now, here's where I was. You can do electromechanical models. We can extract the system model in state space form. We can study the rotation, the control. So a lot of tests that are done on the space station, they are not done on vehicles and vice versa. But my concluding remarks to you are that the generation of the models and the technology that goes into generating models of vehicles is the same as the one that goes into generating space vehicles.